Hello, everybody. Welcome back to Online Chemistry with me, Mrs. Duncan. We're going to continue our talk about acids and bases today. We're actually going to talk about reactions between them, which are called neutralization reactions. So in the two previous videos I posted, we learned how to identify an acid, base, or salt based on its formula. You might want to go back and review that if that all sounds a little hazy. Also, we learned in my last video about the basic properties of acids and bases, and also about two different theories that describe basically what makes something act like an acid or a base. Again, as always, if you need help, have questions, please feel free to reach out to me. What we are going to be learning today is definitely a little tricky. So what I'm going to do is post, in addition to a required practice assignment on neutralization reactions, I'm also going to post extra, not mandatory practice worksheets that I have with answer keys, because in my experience, this is a skill people do need to really practice to feel confident with. So if you do the maybe prior even to doing the required assignment that I'll post with this video, maybe if you're feeling a little shaky on what we're about to learn, you can do those practice worksheets, and of course reach out for help if needed. All right, so without further ado, let's get started. Let's start talking about neutralization reactions. All right, let me pull up my PowerPoint here. Okay. Okie doke. All right, so the basic premise of a neutralization reaction is pretty darn straightforward. You take something, an acid, something with a relatively low pH less than 7, and you react it with a base, something with a relatively high pH, greater than 7. And each time you do this reaction between an acid and a base, you're going to make the same two products. You're going to make water and salt. And we're going to talk about why water is written like this in just a minute. So in this case, yeah, we reacted hydrochloric acid with sodium hydroxide, my acid and my base. I got water and actual salt, like eat it with your French fries salt, sodium chloride. What's going to make this tricky is not necessarily that we always make water. This is always one of my products. It's this, the salt. How you figure out the identity and the correct formula for the salt that is produced by the reaction. All right, so let's keep going. Before we go any further, we've got to do a moment of review of how you identify an acid and a base. If this is not enough for review for you, please go back and watch my first video on identifying acids, bases, and salts. It's really short. It's like less than 4 minutes. It's worth your time if you still are unsure how to identify them. All right, so acids, there basically are two things you look for. Acids, their formulas either start with H, except for water, that's a neutral substance, or they end with Q. So this is table K right here, and this lists a bunch of common acid formulas. Notice they either start with H or end with Q. Really, the only one that ends with Q is this one. All right, so bases, on the other hand, some of you are still falling for this. They do have to have a hydroxide ion in their formula. They have to have an OH, and it's at the end of the formula. The big trick here is that hydroxide ion must be ionically bonded to a metal atom. So some of you are still falling for CH3OH or things like that. That is not a base. Not a base. The reason why is that is a hydroxide ion. Yes, that is criteria is met, but this is a group of non-metals, so that is actually an alcohol. All right, so that is an alcohol, not a base. To be a base, you have to have OH bonded with a metal. This is table L. It lists a couple common bases. Notice ammonia is on there. It is a base. My last video talked about why that is a base. It is a hydrogen acceptor, a hydrogen ion acceptor. Okay, let's keep going then. Let's start talking about actual neutralization reactions. So, I said a lot of this before, so I'm going to go pretty quickly. They always take on the same format. Acid plus base makes water and some form of salt. And that, again, is what is going to be the tricky part. It is not always NaCl. In fact, it's usually not, unless you're specifically reacting hydrochloric acid and sodium hydroxide. Something really important to point out is this is a neutralization reaction, which means the products of this reaction are neutral. So neutral water and all salts, are neutral substances as well. So low pH plus high pH makes middle pHs, neutral pHs. Okay, all these reactions are exothermic. If we were together in class, I would do a demonstration where I would basically react an acid and a base, and I would have a thermometer in the flask, and you would see the reaction actually releases so much heat. I can't touch the flask when it's done, because if it starts out at like room temperature, like 25 Celsius, it's well over 100 Celsius by the time I am done with the reaction. So it's hotter than boiling water, the flask. Okay. All right. So I'm going to talk about this reaction, and then I'll do two others similar to it that are maybe a little bit more tricky. So we're going to talk about where this reaction comes from, how you figure out the products, the NaCl and the H2O. All right, so the first thing that I do when I am looking at a neutralization reaction, so basically we're pretending we don't know that. Okay, so this is my acid and this is my base. And I want to know what happens when I react them together, what the two products that I make are. I know one of them is going to be water. It's always water, H2O. The other one is going to be some form of salt. So let's talk about where the water comes from first, because that part's easier. All right, so here's what I do. I look at my acid and I look at my base. I take the H from my acid and I cross it out. So the H from the acid, I cross it out. And then I cross out the OH from the base. Why am I doing that? Well, because the acid donates that H to the base. And what that really means is the H from the acid, when it's aqueous in solution, the H plus it produces, gets together with the hydroxide ion that the base produces in solution. So that positive hydrogen attracts that negative hydroxide. And you get this, HOH. And if you simplify that, that is H2O. So that's where the water comes from. It's the hydrogen and the hydroxide ions combining to make neutral water. So step one, cross out the H, cross out the OH, and then what's left over? These are going to be the ions that come together to make your salt. So in this case, it's this Na and this Cl that are left after I made the water. So what I would do here is I would do this. I would say, okay, when I make a salts formula, the metal has to come first. So I'm going to take the metal from the base, Na, and the non-metal from the acid, the remaining non-metal, that chlorine. Now in this case, it would be nice because the formula of this salt is NaCl. But if you think back to way earlier in the year when we learned formula writing, it's really important that you look up oxidation states and then cross them down when writing chemical formulas. Sodium has to be +1 to get together with chlorine. Chlorine has to be negative. The only negative oxidation state is -1. So when I cross those down, I get Na1Cl1, which is where that NaCl comes from in the reaction. Okay, so where did I get the salt? I took the metal from the base, combined it with the remaining non-metals from the acids. I looked up oxidation states, and then I crossed them down. All right, so let's try another one. This one's a little bit more tricky, and then we'll try one more. And then you will practice. So, all right, I want to predict the products of this neutralization reaction. All right, so I usually take a second and then I just like identify the acid and the base. Don't always assume the acid comes first. That's my acid, starts with H. This is my base, ends with OH, and K is a metal. And remember what I said, the first thing that I do is I make water. I know I'm going to make water and some form of salt here. So where's the water come from? The water comes from taking the H from the acid and the OH from the base. That makes HOH, which is a different way of writing water. Okay. Some of you are thinking it. I know you are, because every year when I show this, people ask me, well, hold on a second, there's 2 hydrogens here. Yes, there are. And this means this would produce 2 individual hydrogen ions in solution that would have to find 2 hydroxide ions to get together with to make water. Basically, let me put it this way. Don't trouble yourself about there being 2, okay? Just ignore that fact. Just take the H's and the OH's and put them together. We're going to ultimately fix this through balancing. That's why I'm telling you not to worry about if there's more than 1 hydrogen or more than 1 hydroxide ion. Okay, so there's the water. Now I have to make my salt. So I take the metal from my base, which is K, and the remaining non-metal ion from my acid, which in this case is SO4. And if you tell me the formula for the salt produced by this reaction is KSO4, you're wrong. I'm sorry. So if you paused this and tried this yourself prior to me going over it, you're wrong. And here's why. If you got that, it's probably because you forgot this really important step of looking up oxidation states. K's oxidation state is +1. SO4 you find on table E, its oxidation state is -2. So here's where you either use logic or the cross-down method. You might want to put that in parentheses, it's up to you. When I cross down, I would get 2 K's for every 1 SO4. So the formula for my actual salt here is K2 SO4, not K SO4. Okay, so make sure you look up those oxidation states, cross them down. All right, one more together, and then you're going to try this. All right, this is called nitric acid. You can tell it starts with H, reacting with aluminum hydroxide, which is my base. Aluminum is a metal atom. All right, I know acid plus base always makes water plus salt. So I think to myself, where does the water come from? Well, I take the H hydrogen ions from my acid. I combine that with the hydroxide ions from my base, and that's where the water comes from. Remember, that's that HOH, the hydrogens and the hydroxides coming together. Okay, and remember, don't worry about that there's 3 of them. What I forgot to do with the last one was go back and balance the reaction, but if you did, it would fix the fact that there's 3 hydroxide ions present in 1 base molecule. All right, so we got the water. H and OH's combined together. So what's left is going to make the formula for my salt. So I take the metal from my base, the metal has to come first, and the remaining, in this case it's a nitrate ion from my acid. The formula for the salt produced is not AlNO3. Remember, look up oxidation states. Aluminum is +3. Nitrate, that minus sign means it is -1. So when I do the cross-down method, oops, there we go, I end up with 1 aluminum for every 3 nitrate ions. So this is the formula for my salt. I'm almost out of room here, but it would be NO3. 3. Okay, that's the formula for the salt produced by this reaction. All right, so in all seriousness, I know that that is tricky, the salt part. So if you have questions or need help, let me know. I can give you an extension on the assignment if you can't make the first video meeting or you just need some more time, that's fine. And remember, before you try the actual graded assignment, maybe consider doing those extra practice worksheets that I post on Google Classroom. I have heard there's a way to annotate a PDF, so if you don't have a printer, I don't know, you probably use your finger to try it. I don't know, talk to your friends, ask me, I'll try to find out more about that. All right, that's all for today. Hope I see you guys soon. I really do miss seeing you in class. I don't like teaching into my computer monitor. All right, with that being said,